In this video, we're going to take a look at a process called linear programming. This linear programming process is used by businesses to calculate maximizing profit. When you're building something for a company, you want to try to make as most money as possible. To do that, you need to allocate your resources appropriately, and then you also need to be able to maximize your profit. So what you need to do is you need to read problem 5-75 about Otto Toyum, and he's going to be building some toy trucks and cars. And so take a minute to read that question so you have an understanding of what a typical question like this is like. Then once you've read that story, you'll notice that they ask you to make a list of all the possible combinations and plot them on the first quadrant of a graph. So you would literally have to sit here and say, okay, if he's going to have, if it takes, 6 wheels and 1 seat and 3 gas tanks to make a truck and 4 wheels and 2 seats and a gas tank to make a car, how many possible combinations can he have if he has the numbers that are given in that problem? So one of the things you need to do is you'd sit there, okay, well, he could make nothing, which would be 0, 0. He could make 1 truck and no cars. He could make 2 trucks and no cars. Well, eventually you have to stop and think for a second and figure out that the most trucks he could possibly make without any cars is 5. And the reason why, 1, 2, 3, 4, 5, is because each gas tank is 3 and he has 15 total gas tanks, so the most he could make is 5. And then you'd go over to cars. How many could he make? Well, it actually turns out to be 1, 2, 3, 4, 5, 6, 7 is the maximum number of cars. He can make 7 cars because they each take 2 seats and he's got 14 seats available if he made no trucks.
Ashley Miller, call 7798. Ashley Miller, call 7798.
And then what we're going to look for here is what are all the possible combinations? Well, you can't just fill this rectangle in and put a dot here and say that all these possibilities are possible. That's not true because you can't make 7 cars and 5 trucks. The only way you could make 7 cars is if you don't make any trucks. The only way you can make 5 trucks is if you don't make any cars. Then you go to 1 car. Well, if I have 1 car, then I could make a maximum of 4 trucks. Then I got to look at 2 cars. What's the maximum I could get to? And it'll be, 4 or something like that. Now to sit there and figure these out with one by hand, figuring out all the possible combinations takes way too long. So instead there has to be a better way. The better way is called linear programming. So what you need to do is you need to sit down and when you write this workout, the first thing you do is you list out your resources. The resources that his company has available to him are wheels, seats, and gas tanks. You write that down right away. Then how many wheels does he have? You put a little space. Oh, he's got 36 wheels. How many seats does he have? Well, for seats he's got 14, so we put a 14 over here. The other resources he has are gas tanks, and he's got 15 of those. So those are his resources, and that's what he has. So you list those out first. Then secondly, after you figure out what his resources are, you figure out what is he doing with his resources. And with his resources, he's building cars and he's building trucks. And we'll use our cars as our X variable and our trucks as our Y. And then we're going to use that calculation to try to figure out how can he maximize his profit. Okay? And his profit equation, we'll talk about that in a minute, of how much money he makes per car and per truck. All right, so here's the deal. Wheels and cars. So for the wheels on the cars, how many does he have? Oh, that's 4. So we just simply put a 4 there, as in 4 wheels per car. For trucks, if I put those together, that would be 6 wheels per truck. Now, if I'm using my resources, which I've shown here in red, to build my blue items, and my equations are in the black here, well, if I use 4 wheels per car and 6 wheels per truck, if I add those together, how much I'm using, they've got to be less than or equal to the number of wheels I have as a total, which is 36. Then I would go through and do the same thing. This has to be less than or equal to because you can use up to the 36, but maybe you use 34 tires or 35 or something less to make the maximized profit. That's where your decisions are going to be made. Okay, then the number of seats he's got is 2 per car and 1 per truck. Has to be less than or equal to 14. And 1 gas tank and 3 gas tanks have to be less than or equal to 15. Then what you need to be able to do is know how to graph that. Now one way to graph these is to change them into y equals form. I'm not going to spend a lot of time talking about how you change things into y equals form. You should know how to do that. To change these into y equals form, you set them equal to y and you divide and you get these 3 equations. Then what you could do is you could put those 3 equations into your calculator and you could graph all those and see what they look like. What I'm going to show is I'm going to teach you how to graph these with what is called the x and y intercept method. It's a lot quicker. Find an x-intercept, you plug 0 in for y. To find a y-intercept, you plug 0 in for x. Watch. If I want to find the x-intercept, plug 0 in for y, that would cancel. I'd have 0 there. 4 times what number makes 36? Oh, that's 9. If I put a 0 over here, 6 times 6 is 36. That's the number I'm solving for right there. So 6 times 6 is 36. So this is my blue line. The line for the wheels is going to look just like that. Next is I've got the line for the seats. Well, if I put 0 in for y, then the seats maximum would be 7. Could make 7 cars with all seats, and then I could make 14 trucks is way up here. I'm just going to estimate these for right now just to show you how quickly you can graph lines if you just quickly calculate their x and y intercepts. Then here, this would be 15 and this would be 5. So the x number would be 15, which would be way off my page, and this would be a 5, and it's going to cross something like, I got this wrong, it should be a straight line, but I ran out of room here. So what the graph ends up looking like is something like this. So when you actually do graph it, you're going to see that these numbers come up. Now what you're looking for is what is called the feasibility region. So when you graph all these, remember these are inequalities. When we graph inequalities, we're going to shade less than or equal to it. So I'd shade less than or equal to this one, I'd shade less than or equal to the blue one, and I'd shade less than or equal to the red one. Well, where have I shaded in? Well, I've got overlapping shading down here in that whole region. This right here is called a feasibility region. That is what is possible for him to make for the cars and trucks. It's feasible that he could make any combination that's in this area. Now the key points that come up are the points along the vertices of your feasibility region. So we figured out this is our feasibility region in here. Then our key points are right here, here, there, and here. These are the vertices of this polygon known as the feasibility region. Now you'll notice I didn't circle that one. That one doesn't get circled because it's not inside all of the three where all three are shaded. Then I need to figure out these points, and I need to test those points in the profit equation to figure out which is the best deal. Okay, so that's what we're going to do next. So now if you go here to profit, he makes $5 for each car he sells. He makes $7 for each truck he sells. If he makes $5 per car and $7 per truck, our profit equation would be P of x comma y, meaning we're going to substitute in an x and a y to calculate our profit, would be 5 times the number of cars plus 7 times the number of trucks. The points that we need to test in our profit equation are the points or the corners of the vertices to determine the maximum value of the polygon. So, or for the profit. So if I do that, I have it a 0, 0 on the corner. That's right there. I've got 0, 5, which is right above it. That's this point up here. And then I've got 3, 4, 6, 2, and 7, 0. And these are the points that maximize or could potentially use all the resources and make the most money. So you put those into the profit equation and you maximize the usage and the potential profits. Okay, so plug in all those combinations. When you plug in all these combinations, well, 0, 0 is going to give you no profit. If your equation is 5x plus 7y, that doesn't really matter. 0, comma 0 is going to give you $0. Then 0, comma 5 would give you $35. 3, comma 4, well 3 times 5 is 15 plus 28, that's $43 profit. 6, comma 2 is the next one, that gives you $44 profit. And 7, comma 0 gives you $35 profit. So this is the best answer. 6, 2 gives you $44 profit. So that means if he builds 6 cars and 2 trucks, he's going to use all of his resources or maximize the use of his resources, and he's going to make the most profit. Now if you can't find these points of intersection clearly on your graph, you could have put them in your graphing calculator. And when you put them in your graphing calculator in y equals form, remember, we talked about you have to do that, then you could push graph, and then you could see, okay, there's the first line, there's the second line. I could even go back and have this shade underneath, and I could have the triple shading, but now that I've got them in there, I can do second calc, and I can calculate the point of intersection, which is option 5, and I can go through and do all that, and I can figure out, some of the points of intersection, and this one picked this one down here, which was 6, 2. As the first choice, and so then I could use that as one of them. Then I just have to figure out the others. So their calculator can help you with that. So then what you would do is you would go back and you would answer the question. Anytime you do one of these linear programming questions, you need to be able to build the equations, you need to be able to graph them, you need to be able to find the vertices of the feasibility region, and then you need to be able to come up with a conclusion. Otto should build 6 cars and 2 trucks to maximize his profit, is what you would say at the end, because now you've got a conclusion statement and everything's finished up. So you need to be able to write the inequalities, graph them, find the vertices, plug those numbers in, calculate your profit, and you've figured out linear programming. What I'm going to do real quick at the end is I'm going to put up this problem. I want you to pause the video, try it, work it out, and come back and listen to the answer. So pause it now as you're looking at this question about Bob the Builder. Write down the resources he has, write down what he's building, come up with some equations for his profit and so on, find the points of intersection, and see if you can figure out what the answer is. Go ahead and pause now. Okay, now that you're back, the answer to this question would be a situation where he would be trying to maximize his profit, and when he's trying to maximize his profit, he should be using these equations right here. So this is how I built it with the drywall and the studs, and his profit equation is here. And these are the three corners of the graph, and here's my graph that I quickly sketched out. And when I test those 3 points in with these equations, this becomes the best deal. If he makes 6 small sheds and 0 large sheds, he will maximize his profit. Thank you for listening to the video and giving it a shot. If you have questions, talk to your teacher.